Hey everyone, we're going to take a look at 3.2 now in the book about domain and range of functions. So one thing I really want to stress though is to read through that 3.1 fully in the book. There's way more stuff going on in there than I can possibly cover in class or the videos. We will be working with it in class, and like I said, I'm going to make a video that goes along with that because I'm sure we won't finish everything, but if you've never seen it before, it's going to be important that you've at least kind of, even if you just read it and say I don't get this, you can have it in the back of your mind, and when we talk about it in class, maybe we can point it out. One other thing, if you're not familiar with your basic functions, that is on page 174 in your book. I also have a chart that I can put up for you, but this is really a nice, handy toolkit of functions. So it tells you the constant function, which is just like, f of x equals 2, for instance. That's just saying, y equals 2 everywhere, here, there, and everywhere. Also, the identity is when f of x, or we're used to saying y equals x. So we're just going to have a diagonal line across the origin. Absolute value looks like a V. If you're ever not sure what they are, just put in, -2, 0, and 2, just like here. So you can figure out your corresponding y values or outputs, or f of x's, as we now say. Quadratics are your parabolas. Cubics are kind of like just like a squiggle. And the reciprocal function here, or we call it irrational, not irrational, but a rational, where we have a variable in the denominator, also called the reciprocal function. And here's the squared version, where you are going to stay positive. And then square root is really nice and easy to work with, and cube root. So this is more for when you get into pre-calculus. You'll be working with transformations of these, but I think if you can look at these every couple of days for the rest of the term, and you'll have them down in your memory by the time you get to pre-calc, and that will be really helpful. You just need to know the general shape and how to pop in some values and figure out your outputs. You can always do a quick sketch. So here's just the extra exercises and the answers. I usually provide those for you. You just have one document. You can just save it, all the answers for each chapter. So this one now is domain and range. So you're pretty familiar with domain. We've talked about that before. It's what your inputs are going to be. And your range is what your outputs can be. So read through this contextualized problem. I'm not going to read it to you, but that gives you some idea of what it's supposed to be. We usually write the domain and range in interval notation. So I'm going to go through and talk about some of these. We've done this before though, so I'm not going to spend a ton of time with it, but page 181 in your book has that, and I also have that written out on your video companion sheet just for quick reference while you're working on the problems, and you just have a reminder. But we just covered that material, so I'm not gonna go through every little iota again. So I'm going to switch over in a minute. I just want to show you, see how there's some examples here. I'll do ones that are similar, but if you want extra practice, go through here and just, some additional information. How do you convert here, or not convert, but write something in set notation versus interval notation, and reviewing the symbolization needed for that. So we've talked some about that, but here's the three differences, just plain inequality. Set builder notation is with the braces around and using the such that symbol, and then interval notation is having your either a bracket or parenthesis, and maybe you might have a union or intersect. And there's just lots of good stuff in here, more than I'll cover. Okay, so here's your video companion. We're going to look at how to do these tasks. When we're given a function written in equation form, we're going to be able to find the domain. We're going to identify the input values, identify any restrictions on the input, and exclude those values from the domain. That's something you've done before, and writing the domain in interval form if possible. So there's just a reminder of what your intervals are. So number 1, find the domain of each function by using interval notation. So we're going to look at rational functions first. The denominator of a rational function cannot equal 0 since division by 0 is undefined. Okay, so there's a couple of different ways you could think of it as I'm going to set the denominator equal to 0 and figure out what x cannot be, or sometimes we even just set it, sometimes you could just set it right equal to not equal to 0, but however you want to write that up. Technically we want to find when it'll equal 0, and then we're going to exclude that value. Okay, so A, we have f of x equals x minus 5, all divided by 2x minus 1. So we're going to take that 2x minus 1 and find when it equals 0. And like I said, you could write not equals 0 if you want, but so we'll get 2x equal to 1 divided by 2. We get x equals a half. Will give us 0. So therefore, 3 little dots mean in a triangle mean therefore, x cannot equal a half. So we're going to write all the 3 different ways. So our domain, just put a D with a colon. An interval notation, we could write it as negative infinity up to a half, close parentheses, and then put the union symbol, and then another parentheses, a half, comma, positive infinity, parentheses. We could also write the domain in just the regular kind of inequality way, x not equal to a half. We could also write it in set builder notation. So technically we would have this x. I like to write x as an element of all real numbers. So like a double-lined R and then a straight line such that x is not equal to a half. And that's pretty comprehensive. B, we have f of x equals x plus 3 all divided by x squared minus 1. So we may need to factor sometimes. This one we can just use the square root method, would be kind of easy. So go ahead and try that one. Set your denominator equal to 0 and see what you end up with. Same for C, we have f of x equals x over x plus 7. I feel like you guys can handle that. So go ahead and quick do that as a try it. Video try it, okay? All right, so hopefully you've gotten that on your own. So I'm just going to take that denominator, x squared minus 1, set it equal to 0, find when that's going to be 0, and then I want the opposite thing for my domain. I don't want those values in my domain. So I would have x squared minus 1 equals 0, x squared equals 1, x equals plus or minus square root of 1 when I take the both sides, so it's just 1. So you can kind of go through the steps pretty quickly. A lot of these you probably could do in your head as well. It's totally fine at this level. Make that one look a little better. And then what I want to do is say for my domain, I want to just leave it like that because that's what I don't want. So I would say the domain d colon is x not equal to negative 1 comma 1. I could also write it as the interval notation with kind of gets a little long there though for this one. Negative infinity comma negative 1 close parentheses union parentheses negative 1 comma 1 parentheses. Make sure they're curved parentheses too. Just saying closed to know that it ends. And then a union symbol, and then we have a curved parenthesis, 1 comma infinity, and then I'm going to close that parenthesis as a curve. So that would be the interval notation. You can also do the set builder, like here writing like x is an element of all real numbers, x not equal to negative 1, 1. That would be kind of along this line, but we usually don't get too formal with it. The other one here, let's see, x plus 7 in the denominator, so I want to see when that equals 0, and it would be at negative 7. So I don't want x equal to negative 7, and I can write my domain in interval notation, negative infinity up to negative 7, and then negative 7 to infinity. So I have to put my union symbol in between. Sometimes on a test or in the computer, it will specify like which you need to write, and you'll be marked wrong if you don't do it that way. But typically it's a choice. It really just it makes a difference, like what instructor you might have, what publisher, all those kinds of things. So just think about that. And remember, the domain is the set of all input values. I'm going to write that up here up the top. Domain is the set of all input values. And range, squeeze that in here, is the set of all output values. Okay. Okay, so for this next part, we're going to look at even root functions. The radicand must be greater than or equal to 0, since we're only including real numbers. So that's one thing I want to point out too is you can have 0. You can take square root of 0 as 0, and a common mistake students make is they think they can't. They think that it has to be just greater than 0, so just be aware of that. So we will start with f of x equals square root of 5x plus 4. So we're going to take that radicand here, the 5x plus 4. And again, this is really, this time it's what we want. We're not going to do the counterpart. We want it to be greater than or equal to 0. So we're just going to leave it that way. And then we go ahead and just solve. So we subtract 4 from both sides. 5x is greater than or equal to negative 4. And then divide both sides by 5. And I get x is greater than or equal to negative 4/5. So I could leave it just like that in set builder notation. If I wanted to make it, be kind of pretty with the braces, all real numbers, such that I should say x is an element of all real numbers such that x is greater than or equal to negative 4/5, and then just end that with a brace. But again, what I have there in purple is just fine. The interval notation we would write as the negative 4/5, and that is equal to, so I'm going to put a bracket, negative 4/5, comma, infinity, and then a curved parenthesis. So let's go ahead and look at E and F, and then you can try those. We'll do those as video try it, but if you're not comfortable, just, wait for me to do it with you, or just start the video right back, or just leave it run, whatever. One thing I want to point out though, on F here, you're going to do all even roots, okay? So E reads as f of x equals square root of 10 minus x. So you're just going to set the inside the radicand greater than or equal to 0. And the same here for the fourth root. So f of x equals fourth root of x minus 1. So we're getting all even roots, so you can just make that be greater than or equal to 0 for all even roots, okay? And for odd, we can have a negative. It's different. Okay, so now I have the 10 minus x greater than or equal to 0. 10 is greater than or equal to x, and now I'm just going to switch that around, x less than or equal to 10. So I can leave it like that, or write it in interval notation would be negative infinity to 10, and then make sure you have a squared off bracket for that. For f, I'm going to do x minus 1 greater than or equal to 0, add 1 to both sides, x greater than or equal to 1. So I can leave it as that for my domain, or I can write it as a squared off bracket 1 comma infinity curved bracket. Next, I just want to point out that there are some functions that have no domain restrictions, and all real numbers would be their domain. So I think getting familiar with it, but you can see here where we have a linear function. If you know that it's a first degree polynomial, it's just going to be a straight line. So unless there's some context of an application problem, then we're fine. This is just going to go in a line like that, or it might even be the constant function, whatever it is, but any number can be input for x, and I'll get a valid real number. So to come out. So my domain there would be all real numbers, or an interval notation, negative infinity to positive infinity. And that reads f of x equals 2/3 x plus 7. For letter H, f of x equals x squared, and that's our parabola. So being familiar with your toolkit of functions is important. So the quadratic, we have all real numbers, because no matter what I put in there, it's okay, I'll get a real answer. And again, you could write it the same as I did with the interval notation. For letter I, f of x equals the cube root of x, and that one is fine because I have an odd index, and so I don't need to worry about that situation with the even index and having the radicand be positive. So I could have a negative in there, like negative 2 would be the cube root of negative 8, and it works. And the graph for that, I'll draw a little axis here, and then it looks kind of like this. And so we have domain would be all real numbers. So on the next graph, we have finding the domain and range of the graph of a function. So we have a picture of a graph and kind of have a dot, and it descends down and kind of comes back up a little and down again. So we are going to look at the end-to-end for the domain. So this leftmost point is at -5, 5. So I'm going to write that down here, -5, 5. And that's in a closed solid circle, so it's included. If it were open, we wouldn't include it. So I know that's my start. So remember, this is a point that I just wrote. But when I write the domain, it's going to look a little similar. So be careful when you're doing these intervals, and they kind of can look a little like points. And when you write points, it might look like a domain interval or a range interval, but they're not. So you have to really get the context and pay attention to that. I see that happen with students, and it's just, or I could even do it, you just look and you're just thinking, oh, that's an interval, but it's really a point, and vice versa. So just be aware of that. So the domain on this, I would have a closed bracket, starts at -5, but it doesn't end over here. My little tip on the right-hand side has an arrow. So that arrow shows at 4, -9, but it keeps going on and on to infinity. It looks like it kind of just goes straight down, but it really veers off a little bit to the right. So that's going off to positive infinity. So I'm going to write that as the other piece of my interval. So the domain for that is squared off bracket, -5, inclusive, I might say, comma, infinity, and then a curved bracket. So for the range, though, it's what are all the y values allowed to be. So on this, it looks like, again, I'm starting, my highest y is that +5 that I talked about before, and then everything else just kind of descends down to, that heads towards negative infinity, where the x value is kind of going out this way to positive infinity, although it's very, very slight. So for the range, I would write a curved parenthesis, negative infinity, comma 5 with a closed bracket, because that's a solid dot there too. So just a couple more problems in this section, and I'd like you to try them on your own if you can. Number 2, find the domain and range of each function using interval notation. So A looks like just like a little linear line segment starting at the point 2, 8 with an open circle, and then it ends at the point 8, 6 with a closed circle. And then B starts at the point -3, -5, and goes up, crosses the x-axis, has a y-intercept at the point 0, 4, and then comes back down as a parabola to the point 2, 0 with an open circle. So see what you can do with those, and just come back and double check, and then that'll be it for this. You can get into your electronic homework and the paper homework. I will post some more videos, like I said, and also we'll do some in class. Playing with the idea of maybe a group quiz, I'm not sure, or just a short quiz so that we have more class time, because we have that Monday holiday, so it's a little rushed there. Okay, so the answer for this one is domain is parentheses 2, 8 with a bracket. And the range is bracket 6, 8 with an open parenthesis. And I showed you up here, I wrote in like exactly what the domain is here as an interval on the graph. So I have it's starting open circle at 2, goes over to 8 with a closed circle, so you can see how I drew that in there. And then that's how I would write it. Again, it starts to look like points if you're not careful, especially if both ends weren't included. And then the range is the up and down. So I'm going to start at the lower one is 6, and then with a bracket, and then it goes up to 8 with a curved parenthesis. So last one, we have the domain is in red here, so we are including this -3 with a bracket, and then we have the interval of x's that include all the way up to 2, but it's not included, it's open circle, so we put a curve. And then the range, we do want to make sure you always label which is which. Is going to have a closed bracket here, and then starting at the lower one that starts at -5, comma, and then we go in the yellow here, I have it all the way up to the point 4. Okay, so it's like -4, but we just want to put the y value in there, and then a squared off bracket for that one. So thanks for watching. Have a great day.